Basics of texturing are the subject of a separate video tutorial, but in UNIGINE, you might deal with really heavy CAD models that consist of millions of polygons. CAD models are unlikely to have any UV layouts used for texturing, and setting up UV mapping for every surface would be very time-consuming. One more case of hard texturing is when a model has messed up UV mapping and its textures seem overstretched and are not mapped well. For such cases, UNIGINE offers automatic UV mapping. Choose the Triplanar option of UV mapping in the material settings, and textures would be projected from 3 planar surfaces corresponding to the axis. If you deal with flat objects such as floor or ceiling which doesn't have vertical surfaces, Triplanar mapping is excessive. Let's select them, create a new child material for them, and switch to the overlap option to lighten the performance consumption. This option enables planar texture mapping atop the chosen surface. There is no visible change so far, but if you apply the overlapping material to vertically oriented objects, you will notice texture stretching. After selecting the appropriate mapping type, it is easy to assign textures, and they will be mapped correctly. So if you have a problem of inappropriate mapping when applying a texture to a model, simply switch to the Triplanar or overlap mapping mode. You can also tweak texture size and offset by adjusting the UV transform parameter to get better results. The Triplanar blend parameter defines the factor of Triplanar blending for projections. By using these features, you can easily apply textures to geometry with any degree of complexity. UNIGINE materials allow using these mapping modes in absolute coordinates too. For example, if you build complex interiors by cloning and transforming simple blocks, texture scales may differ. To make the size of the textures consistent, toggle the Triplanar World mode on, and you will have a projection that uses absolute coordinates. The UV transform is also available for adjustment in this mode. Textures for planes can be adjusted the same way. Use the Overlap World Mapping mode and tweak texture coordinates to get the floor mapped properly. Now you can create any structure with accurate texture mapping. Please note that this feature is unsuitable for moving objects unless you want to achieve the effect of a projected texture. The Bevel effect allows creating screen space procedural bevels and is easy to control. The mesh on the screen is a low poly mesh with bevels rendered at runtime. By using this feature, you can visually weld separate objects such as these primitives. The feature improves the look of any computer-generated image by beveling sharp edges. Common Bevel settings are provided in the render settings. Mode has an impact on surfaces with normal maps assigned. Let's check the effect on this object. The Better Edges option renders all edges accurately but affects normal maps, while the other mode, Better Normals, ensures that normal maps are not affected, which might lead to the lack of visual accuracy near edges. Choose the mode according to your needs. The Quality parameter determines the number of samples, which has a strong impact on performance. Ultra quality is rarely required, as it provides insignificant visual difference from previous levels. You can also adjust the radius parameter, which is common for all materials that use screen space bevels. The noise setting toggles smoothing of bevels on and off, which greatly improves the look of bevels when low quality is chosen to gain more performance. The Bevel effect is procedural, so we can easily use it for a CAD model. To activate it, just enable the Bevel feature in the rendering menu section and turn on procedural effects in the material states to activate. Now all the edges of the engine are visually beveled and have nice specular highlights, which make details more prominent. You can adjust the intensity for each material via the scale parameter to make the blue case look smoother and the edges of the black part to look sharper. You can also use the Procedural Effects mask for fine-tuning. If you specify a noise texture with a mask in its red channel and enable the Triplanar mode for proper texturing, you may achieve the effect of roughly welded surfaces. The transform might also need some tweaking. The Dirt effect enables you to simulate worn, scratched edges and accumulation of dirt and dust in screen space. It takes into account various slits and cavities which are prone to accumulating dirt, as well as edges which are prone to wear, scratch, and change their initial color. The effect modifies the main screen buffers, such as albedo, metalness, roughness, and specular. For this purpose, the curvature buffer is generated. You can preview it by choosing the corresponding mode in the Rendering Debug panel. Procedural curvature mapping is performed for all objects globally in the screen space, defining their cavities and convexities. The SS Dirt effect is rendered based on this buffer. General curvature settings are available in the SS Dirt section of the settings window. You can tweak quality and buffer resolution, or adjust dirt intensity and radius to define how much the effect is pronounced and how far it is spread over the surface. Threshold and angle bias parameters can be used to apply additional limitation to spreading of the effect. The perspective parameter defines the degree of impact of distance from the camera on the radius of the effect. Lower values assure that the radius is bound to screen space and will remain constant relative to screen size, regardless of the distance of the camera. The values close to 1 make the radius of the effect be bound to world space, and the intensity reduces as the camera moves away from objects. Use the Increase Accuracy flag to remove visual artifacts along the screen edges, if any. By default, the flag is turned off. All these common settings directly affect the final look of the dirt effect. Additional fine-tuning for cavities and convexities is available. These groups contain similar parameters, so we're going to consider them at once. The albedo and shading parameters are intended for the corresponding textures of dirt. Use them to create a different look. For example, an effect of rust on edges in order to make the model look way older. Set texture size to adjust texture tiling. The effect of this setting is more noticeable on the checkered texture. Color multiplier allows achieving the effect of an unusually colored cover. Exponent defines the global intensity of the corresponding components. You can also specify metalness and its visibility for the areas affected by the SS Dirt effect. Check it out by choosing metalness mode in the rendering debug. To use this feature, enable it in the Rendering Features menu. Then enable the corresponding options in the Material settings. First, Procedural Effects, then SS Dirt. If a mesh has UV mapping applied, you can specify your own procedural effects texture, which is used by the SS Dirt effect, along with the SS Bevel. The red channel of this texture is reserved by the SS Bevel feature, while green and blue ones should contain dirt masks for cavities and convexities respectively. But this approach is unsuitable for a CAD model with no UV channels. You can adjust intensity of dirt components per material via the cavity and convexity scale parameters. It is obvious that the amount of dust in cavities doesn't differ a lot, but the intensity of wear on convexities tend to vary depending on the material. For example, metals are prone to erode, while plastic dielectrics are rather polished and clear. The recommended approach is to use the global cavity exponent with minor fine-tuning per material and set the convexity scale for each material individually. Finally, textures and effects have been easily applied to the engine model, which has no UV layouts at all. The look of tiled textures can be improved by using spatial color noise. Use the 2D noise option to apply any additional flat noise texture on any geometry to add some color variations. This effect is suitable for grass or wide floors. Basic parameters of the effect include intensity and UV transform. 3D noise is primarily intended for adding volumetric color variations to vegetation and geometry. The effect treats a 3D noise texture as a mask to project the color taken from the color gradient texture on the geometry depending on its position in space. You can also tweak intensity and UV transform, defining the scale in 3 dimensions. The easiest way to apply a certain texture to any complex shaped surface is to use deferred decals. You can project a label or a texture in a couple of minutes and place it anywhere you need. All features related to decals are shown in the dedicated video tutorial. As for lighting, you can use voxel-based global illumination provided by voxel probes. Unlike the legacy light mapping, this approach does not require UV layouts and provides baked static ambient occlusion and global illumination that consider dynamic lights and objects moving inside the volume of a probe. Check ambient light cast by a voxel probe by enabling the ambient light mode of the rendering debug. Watch the dedicated tutorial for more information about setting up global illumination. There is another simpler option, screen space ambient occlusion, which can be improved by UNIGINE's screen space ray traced global illumination. Simply enable it in the global illumination section of the settings window. Adjust necessary quality parameters and enable the ray tracing option for SSAO. Now we have a pretty accurate picture of ambient occlusion thanks to ray tracing. The SSR-TGI effect provides a result close enough to the one obtained by using light maps, except that it is performed in screen space in real time. For more details on these settings, refer to our online documentation. Now you can use these features efficiently to ensure best look at a low cost, as they can be applied to any kind of geometry to ensure high quality without excessive performance consumption and require no UV layouts.